Okay, so I'm going to show the solutions and how you get solutions for this question that's both on the thermal quiz and one of the thermal homeworks. And the question is how much energy or how much of each substance is required to boil off 100,000 liters of water starting at 250 or 293 Kelvin or 20 degrees Celsius. So to do this, first we need to calculate the amount of energy it would take to boil off 100,000 liters of water at 293 Kelvin. Well, that's 20 degrees Celsius, and we know boiling point of water is 100 degrees Celsius, means a temperature change of 80 degrees Celsius. Now, to calculate the amount of energy it would take to raise 100,000 liters of water by that much, we'll use the Q equals mc delta T equation. Now, M is 100,000 kilograms, because 1 liter of water is equal to 1 kilogram of water. C would be 4.8 Celsius. So Q would therefore be 100,000 times 4.18 times 80, which is equal to 33,440 megajoules. This would actually give you 33,440,000 kilojoules, but we're looking for megajoules because they give us these numbers in megajoules. So that's the energy it takes to raise that much water by that much, up to 100 degrees. Now we need to actually calculate the energy of the phase shift, the energy it takes to boil off that much water. And that's an entirely separate but pretty similar equation. So this, our Q, is equal to mL, where L is the phase shift constant. The phase shift constant for water going from liquid to gas, essentially boiling off, breaking all those hydrogen bonds, that sort of thing, is 2,260 kilojoules per kilogram. We multiply that times the mass of water, which is 100,000 again, and we get 226,000 megajoules. Again, we have to divide by 1,000 after doing this step in order to get megajoules out of kilojoules. Now, to find the total amount of energy it takes to boil off that much water, starting from 20 degrees, we have to add the two. Because this one is the amount of energy it takes to boil it, this one is the amount of energy it takes to get up to boiling temperature. Adding together, we get 259,440 megajoules is the amount of energy required to boil off that much water. Now we need to find out how many kilograms of each of these substances it would take to boil off, to produce that much energy and therefore boil off the water. So, coal is 24 megajoules per kilogram. So to find the number of kilograms of coal, we divide the amount of energy required, 259,440, by 24, and we get 10,810 kilojoules of coal is required. So I've written that in as my answer there. Propane, same equation. Just substitute 50 for 24. And doing that calculation, you get 5,188.8 kilojoules of propane would be required. Then, crude oil, pretty much the same thing, just substitute in 46. Then you get 5,640 kilograms oil. Now, refined uranium, I'm assuming this is fission, because nothing else would produce that much energy. Uranium doesn't burn very well. And doing that, you get 0.07506 kilograms of uranium, or 7.506 grams of uranium. So that's the solution to that problem.